My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 551. In this lecture, I will continue my discussion on vanishing gradient problem. Just before understanding this lecture, I request you to go through my previous lecture on vanishing gradient, that is lecture number 550. In that particular lecture, we were discussing about what is vanishing gradient, why it is occurring, why, because the final gradient, what is this final gradient? The final gradient you are getting here is vanishing, or it's becoming very small or very small because of this chain rule based multiplication. So in a nutshell, vanishing gradient basically means that the derivative that you had with respect to wkij, what is this? Dou L by dou wkij. This derivative becomes very small. This derivative becomes very small because of your chain rule and multiplication of derivatives, and each derivative value is in between 0 and 1 as we are using sigmoid function or tan h activation function. When you have vanishing gradient, what happens? Your wk ij new, your wkij new becomes very similar to wkij old. Wkij new and wkij old, they are very similar, which means you are not moving, you are not updating from old values to new value much because of sigmoid or tan h activation function. Vanishing gradient created a huge problem in 19, I can say it created a huge problem in 1980s, 1990s, even in early 2000, as what is the biggest difficulty? As people could not train deeper networks. People could train maybe 2-layer networks, 2 hidden layers. People could not train 5 hidden layers, 10 hidden layers, 20 hidden layers. This was completely impossible to do because of vanishing gradient problem. What's the problem? Why we could not train deeper neural networks? Because of vanishing gradient problem. Because when you have 5, 10, 20 layers, your weights in the initial layers do not change at all. This simply gets stuck. Building a truly deeper neural network, deep basically means let's have lot of layers. 20 layers network is called, can be deep neural network. A two layer is like okay, it is slightly better than logistic regression. People could not train deep neural networks because of vanishing gradient problem. Remember, one of the biggest reasons for vanishing gradient problem is a sigmoid activation function or tan h activation function. The whole reason why ReLU activation function, function for discovered or created to get rid of the vanishing gradient problem. We will discuss ReLU activation in the next few videos in lot of detail. So this is one of the reason there is a related problem to vanishing gradient is called exploding gradient problem. We will encounter exploding gradient more often in one type of neural network is called recurrent neural networks. We will discuss recurrent neural networks. We will also discuss exploding gradient for completeness. What is vanishing gradient? Vanishing gradient basically means that your derivative of L with respect to any weight wkij becomes very small. This is the problem of vanishing gradient. What is the problem of exploding gradient? Exploding gradient is exactly opposite. Dou L by dou wkij becomes very large. That is also dangerous. Let me explain why. Because if I have weight wkij new equal to wkij old minus eta into dou L by dou wkij, If dou L by dou Wkij is very small, then older value and new value are roughly same. Imagine if dou L by dou Wkij becomes very large, very large, then what happens? Wkij old value is very different from Wkij new, because dou L by dou Wkij is very large. And let's assume your learning rate, let me assume your learning rate is 1 for simplicity. Let me assume let me assume this value, learning rate value, is 1 for simplicity, isn't it? Because dou L by dou Wkij is large, the older value and new value will not change a lot, which is okay in the initial stages. Let's assume I am running iteration 1, 2, 3, 4, so on, iteration 6, so on. So what happens is, from one iteration to other iteration, my weights will change so much. My weights will change massively, isn't it? My weights will change massively as we go from one iteration to other iteration. The difference between these two values, Wkij new, Wkij old, will keep shrinking and converge to solution. But what happens, because you have large derivative, dou L by dou Wkij is large, there is a large difference between your weight Wkij in second and third and fourth iteration. At the end of let me say Wkij one is first iteration weight at the end of first iteration, Wkij 2 is weight at the end of second iteration, Wkij 100 is weight at the 100th iteration. Let me assume what happens. Let me say you will let me say your Wkij value is because of what happens, we will never converge. Literally, even after 50 or 100 iterations, you will not converge, because it keeps changing, because this derivative keeps changing. It's a large value. When it becomes large value, it will never converge. So you don't know where to stop. Weights will change dramatically in all sort of directions. Initially, your weight may be, let me assume, 2.2 and Wkij is 10.8, Wkij 100.6, Wkij 100 is 1 million. Let me assume there is no control. Problem is there is no control over it. There is simply no control over it. The derivative may be dou L by dou Wkij is very large. In the case of exploding gradient, this value dou L by dou Wkij becomes very large, positive or very large negative value. You might wonder, why does exploding gradient occurs again from the same chain rule? Because of the chain rule, you are multiplying lots of derivatives. When all these values are small, we had vanishing gradient problem. Imagine if all these values is greater than 1, which does not happen in the case of sigmoid function, sigmoid activation function. But imagine some function Fij, some activation function, which results derivative is greater than 1. Let me assume this derivative is 2, 2, 2, 2, 2, so on, something like that. If it is 2, 2, 2, if I multiply, what will I get? I will get 8. 8 is which is larger than individual values 2. Individually they are 2, but when I multiply, I am getting 8, isn't it? Activation function, we will see some situations when we learn, we will see such situations when we learn recurrent neural networks. We often find problem of exploding gradient when the derivative becomes large. Why? Because you can't converge. So typically, exploding gradient problem occurs if your derivatives is greater than 1, because in chain rule of multiplication, when we create the because in chain rule of multiplication, which creates exploding gradient, in exploding gradient problem, the weights do not converge and they keep changing erratically. We will see exploding gradient problem when we learn recurrent neural networks. I request all of you to go through this lecture so that I will continue my discussion on neural networks in my next lecture also, that is in lecture number 552. Thank you very much.